Hi, Year 9 students. I'm Norman Wildberger. And today we're going to carry on with our review of decimal number arithmetic. This is going to be the last video in our review, and then in our next video we're going to move on to the Year 9 curriculum proper. Arithmetic is the foundation for mathematics. It's the stepping stone to algebra. If you have problems with arithmetic, algebra will be tough for you. So I'm encouraging you to really make sure that your arithmetic is solid. And that means practice, and it means understanding what you're doing. Not just doing things by memory or by rote. Even basic arithmetic, there are reasons why we're doing things, and I want you to understand what those reasons are. So I'm going to be showing you why things work, and I want you to watch and try to understand yourself why things work. That'll be a lot better for you. Another strong suggestion is to please put your calculators aside. Okay? I know many of you coming from schools where calculators are standard and students are encouraged to work things out with calculators. This is a big error. Okay? It's a wrong direction for learning mathematics, believe me. You want to take every opportunity you can to strengthen your arithmetical skills. Okay, that's going to be the foundation for moving forward in mathematics. Okay, so we're going to be starting with multiplication today, learning about multiplication of decimal numbers, which we're going to see is really not that much different at all from multiplication with ordinary numbers. So some examples. Suppose we want to multiply 0.3 times 0.7. So natural starting point is, well, what are these numbers? Well, we know that we can convert these to fractions, and we certainly know how to multiply fractions. 0.3 is the same as 3 over 10. 0.7 is the same as 7 over 10. Multiplying these is easy because we remind you that to multiply one fraction by another, you multiply the numerators and you multiply the denominators. So this is 21 over 100. And that's 0.21. How do I know that? Well, dividing by 100 really moves the decimal point over 2. Right now when we have 21, there's a decimal point that's sitting there, although you can't actually see it. But it's there anyway. It's to the right of the ones column. If we divide that number by 10, say, then the decimal point moves over and we get 2.1. And if we divide that by another 10, the decimal point moves over yet again to give us 0.21. Alright, so 0.3 times 0.7 is 0.21. And one way of thinking about this is that it's really very similar to just multiplying 3 times 7. In other words, not worrying about the decimal points. So you could just get 21. But then you have to compensate for the fact that there are decimal points over here. 0.3 is actually 1/10 of 3, and 0.7 is 1/10 of 7. So you have to compensate for what you've done by dividing by 100. That's another way of thinking about what you're doing. Here's another example. 1.2 times 0.4. Well, 1.2 as a fraction is 12 over 10. 0.4 is 4 over 10. Multiplying these two fractions is 12 times 4 is 48. 10 times 10 is 100. We get 48 over 100. And what is that as a decimal? Well, we have to divide 48 by 100, which means moving the decimal place over 2, just like we did in the previous example, to get 0.48. How about 2.3 times 1.8? That's 23 over 10 times 18 over 10. 23 times 18 happens to be 414. How do I know that? Well, I just made a little calculation off here on the side. 23 times 18, 8 times 3 is 24. I write down the 4, carry the 2. 8 times 2 is 16, plus 2 is 18, so I get the 18 there. And then the 1, which is in the tens column, times the 3 is the 3, which has to come in the tens column. And 1 times 2 is over here in the hundreds column. And then we add up 4, 8 plus 3 is 11. Write down the 1, carry the 1, which I haven't shown, but it's there anyway. 1 plus 2 is 3, plus that carry 1 is 4. All right, so that's why 23 times 18 is 414, and 10 times 10 is 100. And again, dividing by 100 means moving the decimal place over 2. 1, 2, giving us 4.14. So we see that by converting things to fractions this way, we're really left with the problem of just multiplying the numerators, which are just ordinary multiplications with ordinary natural numbers, and then there's a certain amount of division by a certain power of 10. All right, so there's really these two things together, multiplication with natural numbers and multiplications or divisions by 10, 100, and so on. So those examples that we've just looked at motivate the basic technique for multiplying two decimal numbers. In practice, usually we set things up like a traditional multiplication with one number on top of the other number. Okay. And here's what we're going to do in this context. So let's say we want to multiply 3.4 times 1.8. All right. So I'm going to explain what we're going to do by over here looking at the multiplication of 34 times 18. Now this is not exactly the same problem because these numbers are different from these ones, but you can see that there's a very close connection. So suppose we just want to multiply 34 times 18. We all know how to do that. 8 times 4 is 32, 8 times 3 is 24, carry the 3, we get a 27. And then the 1 in the tens column times 34 is going to give us 34. Then we add up all the digits starting from the ones. 2, 7 plus 4 is 11, 1 here and carry a 1. And then 1 plus 2 plus 3 is 6. All right, so 34 times 18 is 612. So when we're multiplying 3.4 times 1.8, we're going to do essentially the same thing. But we're going to have to compensate for the fact that we're not doing this, we're rather doing a different situation where the numbers are related to these ones by just multiplying by certain numbers of tens. Okay, so the same thing, 8 times 34 would be 272, 1 times 34 would be 34, over here 216 as before. So motivated by the previous slide, we have to remember that this is really 1/10 of this, and 1.8 is really 1/10 of 18. It's because the decimal place that's over here, well, not written, but it's there, has been actually moved over 1 when we go to 3.4. And the decimal place in the 18, which is ordinarily here, is actually moved over 1 to get 1.8. So this number is 1/10 of this number, and this number is 1/10 of this number. And so it makes sense that the answer that we get has to be divided by 10 times 10. 1/10 for this decimal movement over 1, and 1/10 for this decimal movement over 1. So the answer is 6.12. And so I would do this multiplication. I would write it down exactly like this, just writing things down, not put any decimals until the very end. This is just working. And then once we get 612, I would say, all right, we have one decimal here, altogether 2 powers of 10 that have to be compensated for, so we're going to move the decimal place over 2. So let's have a look now at this example, where we have 54 times 0.13. We're going to multiply this as if it was 54 times 13, and we're going to worry about the decimals at the end. 3 times 4 is 12. 3 times 5 is 15, plus 1 is 16. Write down the 6, carry the 1, which then comes down. 1 times 4 is 4 and has to go in the tens place. 1 times 5 is 5. For a total of 2, 0, carry the 1, and 7. Okay, now we have to compensate for the fact that in the original number here, we had a 0.13. The decimal place was not over here, as we computed, but was actually over here. So we actually have to divide this result by 10 times 10, 100, to compensate for the fact that the decimal point is actually here, not over here. So we move it over there. Now suppose that, for the sake of argument, that we had multiplied 5.4 times 0.13. In that case, we would have to divide this thing by another 10. In other words, move that decimal place over yet one more to compensate for the fact that there's also a power of 10 involved in the 5.4. So maybe write the rule something like this, that to multiply two decimal numbers, what we do is, first of all, we ignore the decimal points and multiply as usual. All right. And then we divide the answer by, well, some power of 10, but we divide it by 10 once for each of the original digits to the right of the decimal point. So we look at all the digits which are to the right of the decimal points in both of the numbers, add up how many of those digits there are, and then we have to divide the answer by 10 for each one of those. That's a general procedure that, that you can use. So let me illustrate this important idea with some more examples. 4.01 times 0.03. We're going to pretend that this is just 401 times 3 for now, and then we'll compensate at the end. So 3 times 1 is 3, 3 times 0 is 0, 3 times 4 is 12, which we write down like that. The 0 here has no effect, so we don't even need to worry about things. Okay, so what are we going to do now with this 1203? Well, we have to compensate for the fact that the original two numbers had a decimal place here and here. This decimal place was over 2. This decimal place was over 2. In total, we have to divide by 10 4 times, one for each one of these positions. So the decimal, which starts over here, has to move to the left once, twice, 3 times, 4 times to get 0.1203. How about this example, a bit more complicated? 0.0024 times 1.013. So we're going to ignore the decimals for now and just pretend that this is 24, so those zeros don't matter, times 1013. So we start the multiplication by multiplying by 3. 3 times 4 is 12, carry the 1, 3 times 2 is 6, plus 1 is 72. Then we move over to multiplying by 1. 1 times 4 is 4, 1 times 2 is 2. So notice that we start the 4 in the tens column because the 1s is in the tens column. And then 0. 0 times anything is 0, so we'll just put that 0 there. And then over here, this 1 times 4 is a 4, but now it's got to go in this position, in the same position where the 1 is. That would be in the thousands position if we didn't have any decimal places. 1 times 4 is 4, and 1 times 2 is 2. And now we have to add 2, 7, 4 is 11, 1, carry a 1, like that perhaps. 1 plus 2 is 3, 4, 2. All right, now that's not the answer, of course, because we have to compensate now for the fact that the original numbers actually had decimals in it. So this original number here is actually not 24, it's smaller than 24. 1, 2, 3, 4. There's 4 decimal places over that we have to move. So this number here is actually 24 divided by 10, 100, 1,000, 10,000 actually. Okay, and over here, the decimal point is over 1, 2, 3. So overall, we have 1, 2, 3, 4 positions from the first one, and 3 positions from the second one, a total of 7 positions. All right. So what we really have to do is we have to divide by 10 times 10 times 10 times 10 times 10 times 10 times 10. 10 to the 7. Okay. So how are we going to do that? Well, we have to move the decimal place over. The decimal place starts here, and we have to move it over once, twice, 3 times, 4 times, 5 times. How do we keep on going? Well, we can add some more zeros. All right, well, let's add 2 more zeros. That gives us room to move the decimal place over another 2. 6, 7. So from here, 1, 2, 3, 4, 5, 6, 7. That exactly corresponds to the 1, 2, 3, 4, 5, 6, 7 digits which are to the right of the decimals in the original numbers. All right, how about this example? 0.002 times 1.105. Okay, so again, we ignore the decimals for the time being and just do the multiplication as usual. So these zeros here are not going to contribute at all in this computation. 5 times 2 is 10, so 0, carry the 1, bring the 1 down. 0 times 2 is 0. Let's put the 0 there to hold that place. And then 1 times 2 is 2, which has to appear in the hundreds column. And then this 1 times 2 is another 2, which appears in the thousands column. Then bring them down, 0, 1, 2, 2. And now what remains is to put the decimal place in the right spot. There are 1, 2, 3 places to the right of the top decimal, and 1, 2, 3 places to the right of the bottom decimal, for a total of 6. So we have to divide this number by 10 to the 6. 10 times 10 times 10 times 10 times 10 times 10. So there's 1, 2, 3, 4, 5, 6. We're adding 2 zeros at the front to allow us to move the decimal place over a total of 6. So the answer is 0.002210, and that last 0 is irrelevant. Okay, let me make a little note here. So note that initial zeros to the left of a decimal are here not recorded. I should make a note of this because in many books, when I write something like 0.1203, as I did up here, many books will put a 0 in front of that decimal, and they'll write 0.1203. You might ask why they do that. Well, they do that to minimize confusion. Sometimes it's not entirely clear that this decimal point is a decimal point and maybe not a period from some previous sentence. But we don't have to worry about that. It's a matter of convention whether we want to do that or not, and I'm not going to do that. To make things a little bit simpler and a little bit more elegant, but we have to just make sure that we don't risk confusing decimal points with periods. So if your teacher insists on having a 0 to the left of a decimal when you have something like this, well, then you can do it. All right? So in that case, you put a 0 here, and you would put a 0 here, and you would put a 0 here to the left of the decimal. Okay, so time for some practice. So problem 1, find the products 0.2 times 0.13, 0.7 times 5.4, 1.3 times 2, 16 times 0.03, 4.1 times 0.02, and 0.14 times 3.72. And the answers are somewhere in there. And problem 2, calculate products where they're written one number over another. 3.4 times 5.8, 1.01 times 0.7, 1.08 times 2.4, 0.002 times 89.1, 4.2 times 0.13, and 0.003 times 0.019. Now I realize that you can do this with the calculator, okay? I don't want you to do that. I want you to do it longhand. Okay? I know it's a bit of work. It involves some care and some precision. You have to remember your multiplication tables. Believe me, it is well worth doing this. Okay? I wouldn't be telling you to do it if it wasn't for your own good. It will help you with your understanding of Year 9 mathematics enormously if you get into the habit of making the arithmetical computations yourselves whenever you can, whenever it's reasonable. And the questions that I'm giving you here are quite reasonable. They're not such big numbers, so you will be able to do them. Okay. There's the solutions to the various problems in some more random order. All right, so let's turn to division. Division with decimal numbers, which again is something that many students shy away from and quickly use their calculator. But let's see how it works. Because I want you to understand what's going on. Okay? The basic understanding that underlies what's going on here will be very, very important when we start doing algebra. So let's suppose we want to divide 2.4 by 6. So 2.4 divided by 6. Let's take the approach that we started with the multiplication section by converting each one of these decimals to a fraction and seeing sort of what happens in fraction land, and then converting to a decimal at the end. Sort of to understand what's going on, because we understand multiplication and division of fractions. Okay, so 2.4, if we convert that to a fraction, it's 24 over 10. 24 over 10 divided by 6. Well, in this case, 24 tenths divided by 6 is going to be 4 tenths. And 4 tenths is 0.4. All right, that wasn't too hard. How about 3.5 divided by 0.7? 3.5 is 35 divided by 10. 0.7 is 7 divided by 10. All right, so how do we divide one fraction by another fraction? I have to remind you how to do that. Very important step. It's a lot like multiplication, but with an important twist. Dividing by 7 tenths is exactly the same as multiplying by the reciprocal, 10 over 7. That's the golden rule for dividing one fraction by another fraction. 35 over 10 divided by 7 over 10 is 35 over 10 times the reciprocal 10 over 7. Okay, when we multiply these two fractions, it's product of numerators divided by product of denominators. But before we multiply the product of the numerators and the product of the denominators, we should look to see if there are any common factors that we can conveniently cancel. Because remember, if the numerator and the denominator have the same factors, then things are not changed if we divide by those common factors. And here there is a common factor, 10. So we can divide this 10 and that 10, and we just end up with 35 in the numerator and 7 in the denominator. So 35 over 7 is 5. So it's a lot like 35 divided by 7. In fact, it's exactly the same as 35 divided by 7. So the effects of the decimals sort of to cancel out here, and there's no decimal in the answer. How about 0.8 divided by 0.2? 0.8 is 8 tenths. 0.2 is 2 tenths. 8 tenths divided by 2 tenths is the same as 8 tenths times the reciprocal of 2 tenths, which is 10 over 2. And then when we multiply these two fractions, we should divide the common multiple from the numerator and the denominator, that 10, to just give us 8 over 2, which is 4. A little bit more complicated example. Let's look at 0.91 divided by 0.013. We're going to still adopt the same approach. Convert into fractions, and then use the fact that we know how to divide by a fraction. So 0.91 is 91 over 100. Do you believe that? If you take 91 and divide by 100, in terms of decimals, the decimal point, which is right there to the right of 1, if you divide by 100, you're going to move it over 2, which in fact is 0.91. So that really is the same as 91 over 100. And 0.013 is 13 over 1,000. if you take 13 and you divide by 1,000, you have to move the decimal point over 3. Once, twice, and another one to get 0.013. Okay, then this divided by this is 91 over 100 times the reciprocal, 1,000 over 13. And now again we can cancel some common factors, but the common factor, we have to be a little bit careful. This number is not the same as that number. There's 100 down here and 1,000 up there. We can divide both by 100, cancel 100 from both of those, and just leaving us with 91 over 13 times a single 10 on the top. 1,000 divided by 100 is 10. And 91 over 13 happens to be 7. So we get 7 times 10, which is 70. So motivated by those examples, here is a way of thinking about how to do divisions with decimal numbers. We can simplify things by converting divisions into fractions directly. What do I mean by that? So let's have a look at the same questions that we've just done, but I'm going to structure the solution a little bit differently now. What I want to do is I want to remove our reliance on this division sign. I want to think about 2.4 divided by 6 as 2.4 over 6. Writing it sort of as in fraction form right to begin with. Okay, if I have 2.4 divided by 6, and I think of this as, okay, it's a division, but if I divide 2.4 by 6, I can multiply top and bottom by the same quantity, and the result of the division doesn't change. Okay, so that's what we're going to do. That's our strategy. We're going to write this thing in sort of fraction form, and then we're going to multiply by whatever power of 10 we require so that there are no more decimals in either the numerator or the denominator. In this case, we're going to multiply the top and the bottom by 10, giving us 24 over 60. All right, this is a lot easier to work with. 24 over 60, we can peel off one of these 10s. So we can write this as 24 divided by 6 times 1 over 10. And 24 divided by 6 is 4. So if I have 4 times 1/10, that's 0.4. Let's look at the second example. 3.5 divided by 0.7. We're going to write it as 3.5 divided by 0.7. And now I'm going to multiply top and bottom by 10. That doesn't change the division. 3.5 is multiplied by 10 is 35. 0.7 multiplied by 10 is 7. So this divided by this is the same as this divided by this. But this divided by this is just a regular fraction involving natural numbers, which we can deal with. In this case, we get the number 5. How about 0.8 divided by 0.2? We're going to write it as 0.8 over 0.2. Okay, so very important. We're going to change our point of view. We're going to try to get rid of this division sign. It's a kind of a primary school thing, this division sign. We much prefer to have something over something else to represent division in high school. Okay, so 0.8 divided by 0.2 is 0.8 over 0.2. And now we're going to change this by multiplying both top and bottom by 10, giving us 8 over 2, which is 4. And that fourth example, 0.91 divided by 0.013. So we're going to think about that as 0.91 over 0.013. We're going to think of this as being also a division. And when we divide this by this, we're going to multiply top and bottom by a certain power of 10. And we have to think, well, what power of 10 do we need to use in order that there are no longer any decimals in the expression? Well, we would have to multiply this top one by 100 to move the decimal place over. We would have to multiply the bottom one by 1,000 to get the decimal place over to the right. So what are we going to multiply by? We're going to multiply by the larger of the two numbers that's required. We have a choice between 100 and 1,000. We're going to multiply both sides by 1,000 because that's going to take care of both of them. When we multiply 0.91 by 1,000, the decimal place moves over 3. 1, 2, and then when we move it over once more, we're going to get 910. When we multiply this by 1,000, 1, 2, 3, we're moving the decimal place over 3, we get 13. So what we're really doing is just moving the decimal place over the same amount, top and bottom. That's the effect of multiplying by the right power of 10. Okay, and now we look at this and say, how can we simplify that? The power of 10 is nice to peel all that off separately. And then just think about 91 over 13. 91 over 13 is 7. So we get 7 times 10, which is 70. All right, so this is a reasonably effective way of dividing by decimal numbers in a way that you don't require a calculator. You're basically converting this problem to a problem with natural numbers by multiplying the top and the bottom by whatever power of 10 you need to get rid of the decimals in both numerator and denominator. That's the strategy. All right, so I realize division is harder, and so the practice problems here are sort of on the easier side. I just want you to get used to the idea, this method of taking something like 0.81 divided by 0.9, writing it as 0.81 over 0.9, multiplying top and bottom by a power of 10 so that there are no more decimals visible in either the numerator or the denominator, and then having a look, seeing what you're actually getting. All right, so here are the practice problems. 0.81 divided by 0.9, 7.2 divided by 0.6, 0.125 divided by 0.05, 0.0164 divided by 4.1, and 1,430 divided by 0.011. And there's some solutions. Of course, you better not to look at those solutions before you try the problem. Okay, so in our final topic here in this final review video, let's have a look at some common fractions expressed as decimals. It's important to have some familiarity with some basic fractions as decimals so that we can go back and forth from decimal world to fraction world reasonably simply. All right. So a very simple decimal, 0.5, that's the same as the fraction 1/2. Another one, 0.2, is the same as 1/5. 0.1, even simpler, is 1/10. 0.01 is 1/100th. These are absolutely sort of basic ones that you have to know immediately. Okay, 0.5 is the same as 1/2. 0.2 is the same as 1/5. 0.1 is 1/10. 0.01 is 1/100th. Here are some slightly more complicated ones that are also useful. These two are especially important. 1/4 is 0.25. 3/4 is 0.75. And another useful fraction to know the decimal of is 1/8. 1/8 is 0.125. All right, so please memorize these two, and if you remember this one, it's probably good. And let's make sure that we understand what we're talking about here. Here is the number line from 0 to 1 divided into 10 pieces. There's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and up to 1. Okay, and these various fractions that are appearing here are where? Well, 1/2 is right there. Okay, so in terms of fractions, there's 0, 1, there's 1/2. 1/5 is right there. That's 1/5 of the whole interval. 1/10 is half of that. That's right there. 1/100th would be, well, 1/10 of this somewhere in there. 1/4. 1/4, well, that's halfway between 0 and a half. There it is there. It's 0.25. So 0.2, there's 0.3. 0.25 is exactly halfway between 0.2 and 0.3. So there's a quarter. And 3/4 is 0.75. That's halfway between 0.7 and 0.8, right there. And the other one, 1/8, is right about here. 0.125. There's 0.1, there's 0.2. 0.125 would be, in fact, a quarter of the way along here, so just right there. All right, so please remember these correspondences between some basic fractions and decimals. So if you see 0.75, you should know, that's 3/4. If you see 0.2, that's the same as 1/5. 0.5 is the same as 1/2. This one's not bad to remember too. Well, what would happen if you forget what 3/4 is as a decimal? Is there some way of figuring out what it is? Well, yes, there is. And this method also works for figuring out what the decimal is for any fraction. So we can get a decimal for any fraction by long division. Okay. But we have to remember that what we might get is an endless repeating decimal. That can happen. We don't always get finite decimals, and there's a very important example, this example of 1/3, that we have to remember what's happening there with a repeated decimal. So let me show you how you would get the decimal for 3/4 if you forget what it is. It illustrates the method. 3/4 is 3 divided by 4. That's what 3/4 is. So we could divide 3 by 4. Now in primary school, you would say, well, 4 doesn't go into 3. The answer is 0 with a remainder of 3. But if we allow ourselves decimals, then we can think about 3 as being the same as 3.0. In fact, it's the same as 3.00 or 3.00. We can add as many zeros to the right of the decimal point as we like. It doesn't change the number. So what we can do is we can do long division in decimal fashion. And let me illustrate how that goes. I might do it over here. Okay, so 3.000. I'm going to put a decimal right there. So we ask how many 4s fit inside 3. This is long division. Okay, there are no 4s that fit inside 3. Okay, fine. But then we go to 2 places, 3.0, and ask how many 4s go into essentially 30. And the answer is 7. Well, actually, it's how many 4s go into 3.0, and we're going to put a 7 here to the right of this decimal, which is up above the decimal place here. So this is really 0.74s that go into 30. All right, so 4 times 7 is 28. So we're going to subtract those 28, but it's actually 2.8 that we're subtracting. We're going to subtract 2.8 from 3.0 to get 0.2. Okay, now we can drop, well, we ask how many 4s go into 2? None. But how many we can drop another 0 down? This is just like long division without decimals. And then we would get 4 goes into 20 5 times. And 5 times 4 is 20. Actually, there's a 0.2. And with a remainder of 0. All right, so that's how you would get 0.75 by actually dividing 3 by 4. Let's see if we can get 1/8 this way. Might try to do it here. So 1 is the same as 1.000. How many times does 8 go into 1? It goes 0 times. Well, how many times does 8 go into 10, or actually 1.0? It goes once, actually 0.1 times. And that would be 0.8. When we subtract, we get 2. Then we drop down to 0. And how many 8s in 20? Well, 2 of them, for a total of 16. Actually, there's a point here. Okay, and then we subtract, that's 40, 4, and then the 0 comes down. And how many 8s go into 40? Well, 5. And then there will be 40, and well, we have to put 40 underneath here, and then subtract the remainder of 0. So the answer is 0.125. Okay, let's have a look at this one here, 1/3, or 1 divided by 3. This is a very interesting thing. We'll do it over here. So 1 divided by 3. 1 is the same as 1.000 if we want. So how do we do that long division? Well, how many times does 3 go into 1? 0 times. How many times does it go into 1.0? 0.3 times. It's just as you would do ordinarily, where there just happens to be a decimal point in that position. You can almost ignore it if you want. 3 times 0.3 is 0.9. Subtract, we get a 1. Actually, a 0.1. Drop the next 0 down. We're exactly in the same position as we just were. How many 3's go into 10? 3. 3 times 3 is a 9. Then we drop down, we get another 1. Then drop another 0. We keep on getting 1, 0, but further and further over to the right. So this pattern of 3's just keeps on going. So we get that 1/3 equals 0.3333, and so on. You could keep on generating 3's by keeping on doing the long division. The long division never stops. You never get a remainder. This is just one of the facts of life when you're working with fractions in the decimal world. Now we usually introduce some simplified notation for that. We just put a bar over that 3 to represent that 3 is repeated. So that's a very important decimal expansion to know, that 1/3 is 0.33333. And if you're actually using it in practice, well, you would just chop it off at some convenient point. You might use 3 or 4 or 5 digits and forget about the remaining ones. Just accept the fact that there's a little bit of an error when you're working with decimals instead of fractions. All right, so our final practice for today. We've covered a lot of material. Some of you will know this material very well. That's great. You'll just have a bit of a review. And the way I'm been explaining things might be a little bit different from the way you've been taught. That's fine. There are different ways of approaching arithmetic with decimals and fractions. As long as you have some effective and efficient way that works for you, that's good. Okay, you don't have to convert to my way of doing things. But I do want you to be able to make these computations. And for those of you who do not have a strong background in arithmetic, please listen to me when I say that's very important that you try to develop some more. And doing these problems, seeing if you can get the same as the solutions that I've put down here, it's a great way of making progress and strengthening your mathematics, preparing you for year 9. Okay, so our practice is to write these fractions as decimals. 2/5, 7/10, 6/5, 3/2, 5/4, 3/8, 13/100. Write them out as decimals. And the second problem is to use long division, just like I've just shown you, to find repeating decimals for 2/3, very important one, 4/3, 7/3, 1/6, and 5/6. And the solutions are like this. This one here, what does it mean? 0.83 repeated. The 3 is repeated. There's a bar over 3, but not over the 8. So this means 0.833333, etc. All right, so very good. We've done a review of, well, some very important things that you probably want to know before we start Year 9 Maths. So in our next video, we're going to start with the Year 9 curriculum. And our first topic will be index laws and powers. I hope you'll join me for that. I'm Wildberger, and we'll see you all next time.